Welcome to this explainer. I'm so thrilled you're here today because, well, we're going to expose a bit of a secret. Whether you realize it or not, there's this hidden architecture, a hidden math, that is silently running almost every aspect of our everyday lives. From the bills we pay at the end of the month to the services we hire for our homes, mathematical functions are dictating the costs. And today, as we dive into Unit 11.1 on functions, we're going to learn exactly how to read that hidden code.
So think about the last time you hired a professional. Maybe it was a plumber to fix a really stubborn, leaky sink, or perhaps you rented some heavy equipment for a weekend yard project. How did you figure out the true final cost before the job even started? If you just kind of guessed, you might have ended up with a pretty nasty surprise on the final invoice. To predict those costs perfectly, we have to translate real-world language into mathematical reality.
Let's look at a really concrete, real-world scenario straight from our source material. Imagine a plumber comes over to your house. You ask for a quote, and the contractor says, "I charge a fixed fee of $45 plus $30 per hour." Sounds simple enough, right? But how do we actually turn that casual, everyday English sentence into a tool we can use?
Okay, let's dive into this. That quote from the contractor? It easily translates into a mathematical mirror image. We literally just turn the words into an algebraic equation. That $30 per hour becomes 30H, and the fixed fee is just tagged right on the end as plus 45. We'll let the total cost be represented by C. Suddenly, a casual quote is this precise, rock-solid formula. C equals 30H plus 45.
Now, the real magic here relies on what we call variables. A variable is really just a letter used to represent an unknown number or a quantity that can change. So in our plumber example, H stands for the number of hours worked. Obviously, that's going to vary from job to job. And C stands for the total cost, which changes depending on H. By using letters, we create this incredibly flexible template.
And that template is what mathematicians call a function. A function is essentially a rule. It shows the exact predictable relationship between our variables. You can really think of it as a master key. Our equation, C equals 30H plus 45, isn't just the answer to one single specific plumbing job. It's a master function that lets us solve literally any variation of this cost problem, no matter how long the plumber is at your house.
Let's actually put this master key to work. Say the plumber works for exactly 3 hours. First, we take our function, then we use a super simple process called substitution. We just swap out the variable h and replace it with the number 3. We multiply 30 by 3 to get 90. Finally, we add that $45 fixed fee, so 90 plus 45.
Boom! $135. By using the function, we perfectly predicted the plumber's final bill without breaking a sweat. There's no guessing, no rough estimates, just pure deductive algebraic logic.
But here is the absolute beauty of mathematical functions. They aren't limited to just one profession. They govern entirely different situations all around us. So, let's completely switch gears from plumbing to party planning. What if you need to hire a hall for a big event? Let's say the venue gives you this pricing structure. There's a booking fee of $15 and a charge of $40 per hour. Now, look at the structure of that sentence. It feels awfully familiar, doesn't it? I challenge you right now. How would you translate this into a mathematical function?
And this brilliantly illustrates the absolute universality of algebra. The venue's quote perfectly maps to our new function, C equals 40n plus 15. The total cost C equals $40 multiplied by n, the number of hours, plus that $15 fixed booking fee. It's a totally different scenario with completely different numbers, but it's exactly the same underlying structure.
Now, what's really fascinating here is how we can visualize this as a sort of function machine. Think of it as an input-output table. If we input 3 hours for n, the machine multiplies it by 40 and adds 15, spitting out an output of $135. If you input 6 hours, it predictably outputs $255. It systematically maps inputs to outputs in a perfectly reliable, unbreakable pattern. Honestly, once you see this pattern, you start seeing it everywhere. Translating the world into functions just becomes second nature. Buying theater tickets for $12 each with a $3 service fee, that's D equals 12T plus 3. Hiring scaffolding for $80 delivery plus $50 a week, that's Y equals 50W plus 80. Buying books online for $6 each with $4 shipping, that's C equals 6B plus 4. The entire modern economy is basically running on these simple algebraic rails.
But hold on a second, beware. If you don't use these functions properly, your intuition can actually lead you into a very common and, frankly, very expensive mathematical trap. Let's test this out. If a car rental costs $340 for 7 days, simple logic might suggest that doubling the days doubles the price, right? So, does it cost $680 for 14 days?
Well, to find the truth, we have to uncover the hidden function. According to our source material, the actual pricing structure for this rental car is a fixed fee of $25 plus $45 per day.
Let's look at a student named Sophia from our source text who fell right into this trap. First, she knew 7 days cost $340. From there, she reasonably assumed 14 days is simply double that amount, arriving at $680. But here is her fatal flaw. By just multiplying the final cost, Sophia accidentally paid that $25 fixed booking fee twice.
So the crucial point here is that trusting a function is always safer than your raw intuition, especially when fixed fees are involved. Compare Sophia's guess of $680 to the actual function. A equals $45 times 14 days, plus one single $25 fixed fee. The true cost is $655. Understanding functions just saved you $25.
Now, let's see how all this builds when we completely flip the script. So far, we've always had the input, like the number of hours or days, and calculated the final cost. But what if we're playing detective? What if we know the final cost, but the input is a complete mystery? Well, it turns out functions can actually be run in reverse.
Let's look at a guy named Marcus. The function for printing his photos is $2 per photo plus a fixed charge of $3. We check his receipt and we see Marcus paid exactly $49 in total. Our mystery is, how many photos did Marcus actually print?
We can literally use the function to work backward. First, we write the function out with our known output, 49 equals 2n plus 3. Next, we need to isolate our variable. We do this by peeling away the layers. We start by subtracting that $3 fixed fee from both sides, leaving us with 46 equals 2n. Finally, we divide that remaining $46 by the $2 cost per photo. And just like that, the mystery is solved. By running the algebraic function in reverse, we deduce that Marcus printed exactly 23 photos. This is the incredible, undeniable power of isolating a variable.
Now, as we've gone through all of this, a skeptical question might have popped into your head. In fact, it's a question directly posed in the textbook we're analyzing. Why do you need to describe situations like these with a function when you can just describe them in words? Honestly, it's a super fair question. Why bother with all this algebra if the English sentence makes perfect sense? Well, the short answer? It gives us superpowers. Moving from concrete words to abstract math allows us to avoid repetitive manual calculations. As we saw with Sophia, it completely prevents scaling errors when dealing with fixed fees. Functions let us instantly predict outcomes for literally any quantity, whether it's 3 days or 3,000 days. And, as you'll see as you continue your studies, this algebraic structure bridges the gap to plotting visual graphs, which allows engineers and financial planners to effortlessly model the future.
So, as we wrap up this explainer on Unit 11.1, I have a challenge for you. Take off the blinders and try looking at your daily life through this new mathematical lens. From your streaming subscriptions to your monthly utility meters, from ordering takeout on an app to booking a flight, look around you. What hidden mathematical functions are silently calculating your next bill? Thank you so much for joining me to explore the elegant math hidden in plain sight. Keep looking for those functions and keep learning.